which records the log entries to the Sega Master System and Sega Genesis. There are other formats too, like the SPC, which is the Super Nintendo. These are very small files. This one you're hearing is 68K. It's a format similar to like a mod file. And SID, very popular. But for the purpose of this presentation, we're going to be focusing on BGM files, which is what you're hearing right now. Now, BGM files actually have the register information for the, both of the audio chips in it. It is also the format for the master system, which is an 8-bit version of the chip. Now, you could get BGM files from many sites. One of them is Project 2612, which has like every Genesis game soundtrack. Also, you can get it from SMS Power, which created the BGM format and has Master System soundtracks. And what inspired me to research the Genesis audio was all these projects that I saw online. Particularly was this NSF player, which is a hardware NSF player. It's like a self-contained circuit that plays back a file. And there was these other projects, like the people playing around with the audio chip of the FM chip, the PSG chip, so I thought, why not make a little Walkman-like device that can play VGM files. You heard Sonic the Hedgehog playing back on this player, but it's actually running through an emulator, so some of the things don't sound exactly quite right. So I wanted to create a little player that would play back the audio 100% perfectly, and what better way to do that than to use the actual chips. All the information is online. I have the schematics, the documentations, the data sheets, the VGM formats all spec'd out. I have all the music files. So all I have to do is just put it together, and having no electronics experience, it would be quite interesting. So this site, mudocs.org, has all the documentation you need, the schematics, the data sheets for all the sound chips. When I first looked at this, I had no idea what I was looking at, but it looked pretty cool. Pinouts for the FM chip, the VGM spec. And what led me to believe that I could do this project is there's this text here that says YM2640, write value DD to register A. So I remember seeing that before. I saw it on this pinout. You see it says write to part A register, write to part 2 register. It maps to that BGM file format. So I thought there must be a way to get this file directly to this chip. And apparently I was right, so it led me to create this device that streamed the BGM file data to those chips. And in doing so, I learned a lot about how the Genesis creates its sound, and I'll play back a little sample for you. This circuit took about 5 months to complete. It's running all from battery power. I keep all the VGM information on these little EEPROMs, which are 32K worth of information. So I'll go into the details of how what I learned. We can start with the PSG chip. That's the simplest chip to learn. It's found in many game consoles, arcade, computers. You're seeing here is the Sega 1000. It's also found in the Sega 3000 Mark III. It's also in the Game Gear. It's a very popular chip. It's in the ColecoVision, it's in the Sega Master System, and of course in the Genesis. So I thought this was a good place to start to learn how this chip produces audio, how to get data into it. The data sheet gave me this information, has 3 square wave tone generators and 1 white noise generator, which sounds like static. Here's a little sound of the chip. This is from Sonic the Hedgehog 2. It's the PSG playing in the background. You hear it so light you don't notice it. It's very muted, but it's playing in the background of Sonic the Hedgehog 2, Emerald Hill Zone. Sounds very similar to Nintendo. So to get sound out of it, you write registers to it. So that's what the PSG sounds like. It stands for Programmable Sound Generator. It's an integrated circuit with everything you need in it. It has an audio mixer, has a built-in oscillator, so all you need to do to get data out of it is write to each of the pins. So how do you do that? See, these boxes represent a channel. This represents one of the tone channels. There's 3 square wave tone channels and a white noise generator. And to access those, you write binary on, off, in just 1 byte to access each of those channels. So depending on what you write to the chip, you can turn off channel 3 volume or set the frequency to a higher setting. I'll go into this registers later. How do I know the PSG chip existed inside the Genesis? Well, it was inside the schematic. You can see the PSG chip here and the FM chip here. I didn't know the PSG chip existed until I saw this document. They both mix into this circuit. Mono, stereo, mixes into the headphone jack. So I thought this was great. How do I get data into it? Well, the first thing I needed to know is hex to binary conversion. The image you see on the left in red, that's the VGM file data. That's the instructions in that file that has all the music, register changes you need to do, set the channel on or off. And these pins, you remember that pinout has D0 through 8. So just take those hex values, convert them into binary, and just map them to the correct pins. Just dump them like a player piano. How do I do this? Well, there's this tool called Arduino which let me do that very easily. Its IDE is very easy to use. It lets me control this microcontroller, which lets me set these pins, digital pins on the top, to on or off very easily. Like you can see in the code, digital write pin, set pin 6 to 1. So that's the first prototype I did was to stream a VGM file through serial port, send it to the Arduino, parse it out into the 1s and 0s, and send it to the FM PSG chip. I got this idea from Little Scale, this website that did a similar project. And here's a video of it playing. So from my computer, the VGM file streams to the serial port, USB. So it works. Problem was, I ran out of pins. To implement the VGM player, I'm going to need the other FM chip, which has more pins than the PSG chip. As you can see here, it's all filled up. I don't have any more pins to write data to. So I had to look into shift registers. What shift registers allow you to do is send more data out using fewer wires. So you remember the byte example I showed you? You could fill up 8 bytes just directly connecting the pins to it. Well, in this example, you take one bit and you push it out one at a time. So if you can imagine, I fill in a bit into this box over here and then move it over to 6 and then push another bit, 0, push it over. And it keeps going, keeps going. Once this is filled, it moves on to the next one.